Hello, my students in grade 8. I hope you are all fine and safe with your family members. This week, I will continue in our first lesson, which is powers, but this is lecture 2 in this lesson. I sent the lecture 1 last week, and this week we will be talking about the rest of the rules. What are the objectives of our lesson for this week? Number 1, as a reminder, I will remind you of the last thing I talked about last lecture, which are powers having a negative exponent. Number 2, we will continue in our rules of powers, but the rule I'm going to talk about this week is powers having a negative base. So last time we talked about powers having negative exponent. This week we will talk about powers having a negative base. How do we deal with these powers? Number 3, together we will recognize a number written in scientific notation. Let me remind you of the rule we talked about last week in case of a power with a negative exponent. So I have 3 rules. If I have a to the power minus n, the first thing I can see is this power has a negative exponent, which is minus n. Always, as I said, whenever I have a power with a negative exponent, it should be changed to a positive exponent. To change it to a positive exponent, first it should be written as a fraction. So what I do is a to the power minus n, I change it to a fraction, I write it over 1. Now, the negative exponent in my fraction is in the numerator. To change it to a positive exponent, I take it down to the denominator. And since I have nothing in the numerator, I have to write 1. So a to the power minus n equal 1 over a to the power n. As an example, 10 to the power negative 6 equal, I change it to a fraction, 10 to the power negative 6 over 1. Now, the negative exponent, I write it in the denominator to become positive, so it is 1 over 10 to the power 6. Why did I write 1 here? Not because in the denominator I have 1, no, but since it's written nothing over 10 to the power 6, nothing in math, I write a fraction of a numerator 1. The second rule, 1 over a to the power minus n. Now, the negative exponent is in the denominator. So to change it to positive, I take it to the numerator. So it becomes a to the power n over 1, which is a to the power n. For example, 1 over 10 to the power minus 11. To change it to positive, I take it up, so it becomes 10 to the power 11. The last rule, a to the power minus n over a to the power minus m. Here in the numerator, I have a to the power minus n. I take it to the denominator, it becomes positive. The denominator, a to the power minus m, I take it to the numerator, it becomes a to the power m over a to the power n. For example, 5 to the power minus 4 over 5 to the power minus 6. It is 5 to the power 6 over 5 to the power 4. Now here I am dividing two powers having same bases, different exponents. So I keep the base 5 and I subtract 6 minus 4, which is 5 squared. Now 5 over 10 to the power negative 4. In the numerator, I have 5, so I keep it 5. 10 to the power negative 4, I take it up, so I multiply it with the 5. This is as a reminder of what we did last week. Now, if we are talking about powers having negative bases, now if you look at this power here, you can see that I have minus a to the power n. Now, my base is negative, minus a. Whenever you see a negative base, all of it to the power n. So always, to be a negative base, it should be written in parentheses and the exponent outside. So this is how a negative base is written. It should be always inside parentheses and the exponent is outside. Here I have two cases. always, whenever we have a negative base, I look at my exponent at n. If n is even, so my answer will be positive. It will be a to the power n. For example, minus 2 to the power, all of it to the power 4. I have a negative base between parentheses and the exponent is 4. You know what do we mean by even? These numbers that are divisible by 2. For example, 2, 4, 6, 8, 10, etc. So I look at my exponent, which is 4. 4, since it's even, so my answer should be positive. As you can see here, I have no sign, which means it's positive. And I get the answer of 2 to the power 4, which is 16. 2 times 2 times 2 times 2, which is 16. Minus a 3 squared. Also, I have a negative base. My exponent is 2, which is even. So my answer should be positive. Positive, we write plus or we can write nothing. Now I get the answer of 3 squared, which is 9. The second case, if n, the exponent, is odd. What do I mean by odd? 1, 3, 5, 7, 9, 11, whatever. My answer will be negative a to the power n. For example, minus 4, all of it cubed. So my base is negative. I look at the exponent. I ask, the exponent is even or odd? It's odd. So my answer will be negative or positive? It will be negative. And I find 4 cubed, which is 4 times 4 times 4, which is 64. Minus 1 to the power 9, I have a negative base. My exponent is odd, which is 9. So my answer will be negative. And 1 to the power 9, this is a rule, it gives me 1. Minus 2 cubed, always, since I have a negative base, my exponent is odd, so my answer will be negative, and the answer of 2 cubed is 2 times 2 times 2, which is 8. Please practice this rule. It's very, very, very important, and study the 2 cases well. Now I will continue. Let's practice these exercises together to see the difference between this way of writing and this way of writing. I have minus 2, all of it squared. This is a negative base. Why? Since it's written in between parentheses and outside we have an exponent. So here the exponent outside is for both, for the sign and the number. So I ask, is my exponent even or odd? It's even. So my answer will be positive or negative? It will be positive, of course. And we find 2 squared, which is 4. Minus 2 cubed. So I say, here, my exponent is even or odd? It is odd. So my answer will be negative, and 2 cubed is 8. Minus 1, all of it to the power 7. This is a negative base. My exponent is odd, so my answer will be negative, and 1 to the power 7 is 1. Minus 1, all of it to the power 4. This is a negative base. My exponent is even, so my answer will be positive, and 1 to the power 4 is 1. Let's look now here. Is this way of writing similar? What's the difference between this way and this way? Here, the base is written between parentheses, so we apply the even and the odd. Here, the base is not written between parentheses, so this is not a negative base. Here, the exponent is only given for the number. It has nothing to do with the minus. So as they will say, the exponent here is only for the number. So what should I do? I say the minus is written as a minus, and I ask 1 to the power 11 is 1. Here, it's not a negative base, so I always write minus, so I don't look at the exponent if even or odd as I did here. No, I write minus, and 2 to the power 4 is 16. Minus 2 cubed, I write minus, and 2 cubed is 8. Minus 1 to the power 8, I write minus, and 1 to the power 8 is 1. Now let's look here. I have minus parenthesis minus 1, all of it to the power 5. First, I have minus outside, so I leave the minus outside. Here I have a negative base. Is my exponent even or odd? It's odd, so my answer will be negative, and 1 to the power 5 is 1. So I write minus into minus 1. Now, negative times negative is positive, so my answer is 1. Please, this exercise is very important. Practice it well. Now, the last thing I will talk about is recognize the form of a number written in scientific notation. This is very important. What do we mean by scientific notation? It is a way to shorten very big or very small numbers. So if we have very big numbers or very small numbers, we can shorten these numbers, or we can write a number in a simpler way. To write a number in scientific notation, we should write it in this form always. A number which is a times 10 to the power m. So a number multiplied by 10 by a power of 10, which has an exponent m. So I say the number a should be a number always between 1 and 10. So a should always be a number between 1 and 10. So a, 1 less than or equal a less than 10. What does less than or equal mean? A can be 1. So it can be 1, 1.1, 1.2, 1.38, 2, 3, 4, 5, 3.5, 3.6, 7.9, 9.8, but it cannot be 10. So this number cannot be 10. It should be a number between 1 and 10. And m here is an integer. What do I mean by integer? It can be a positive number or a negative number. For example, write these numbers in scientific notation. I have 973. The first question you should ask for yourself whenever you are writing in scientific notation, is this number 973 a number between 1 and 10? No, it's more than 10. I should make it a number between 1 and 10. How do I make it? I should put a point in this number to become between 1 and 10. Where should I put my point? My point should be written between the 9 and 7. So 9.73, now it's a number between 1 and 10, times 10 to the power, how much? I say I have 973 to become 9.73. This is a whole number. You know that in a whole number, always it's 0.0. So the point is near the 3. To become between 9 and 7, I move it from 1, 2. So I moved it 2 digits, 1, 2. So I multiply by 10 squared. 49.12. Now this is a decimal number. Is it between 1 and 10? No, it has a point, but it's 49. It's more than 10. Let's make it between 1 and 10. So I should put the point between the 4 and 9. I moved the point from here to here. So I moved it 1 digit. So I multiply by 10, or 10 to the power 1. 7, is it a number between 1 and 10? Yes, so I should leave it as it is. I'm not moving the point anywhere, so I multiply by 10 to the power 0 if I'm not moving anywhere. 290,000 also should be written in scientific notation. Is it a number between 1 and 10? No. Let's make it, the point should be written between the 2 and 9. So my number should be 2.9 times. I move the point 1, 2, 3, 4, 5. So 10 to the power 5. Let's solve these together. The first number, is it between 1 and 10? No. I should make it, let's make it between 1 and 10. So the point should be written here. So it's 7.00000. So I write it as 7. How much did I move the point? 1, 2, 3, 4, 5, 6, 7, 8. So it's 7 times 10 to the power 8. Is 13 a number between 1 and 10? No. Let's make it. It should be 1.3 times. I moved it 1 digit. So 1.3 times 10 to the power 1. Is this number between 1 and 10? No, let's make it, the point should be written 4.81. How did I move it? 1, 2, 3, 4, 5, 6, 7. So 4.81 times 10 to the power 7. 1.6, is it a number between 1 and 10? Yes. So the point should not be moved. So I multiply by 10 to the power 0. 8, is it a number between 1 and 10? Yes. So I should keep it as 8. So I write 8 times 10 to the power 0 since I'm not moving the point anywhere. Now, 4,621.7, is it a number between 1 and 10? No. The point should be written between the 4 and the 6. So it should be 4.6217. How much did I move the point? 1, 2, 3. So 4.6217 times 10 to the power 3. Now, I have 0.000003. This is a number less than 1 since it is 0 point. So here, since these numbers are greater than 1, I am multiplying by a positive power of 10. When my number is less than 1, which is 0 point, so I should move the point 1, 2, 3, 4, 5, 6 to become 3. I moved it to the right, so I should write a negative power of 10, 3 times 10 to the power negative 6. 0.00472. Also, I should move the point 1, 2, 3, 4.72 times 10 to the power negative 3, not negative 4. This is a typing mistake. So this was our lesson for this week. Please watch the video well, understand the rules, and practice the exercises. And if you have any question, please contact me directly. Thank you.